Example number 50, evaluate the integral from 0 to 1, x dx over x plus 1 squared by x plus 2. So, that is resolving into partial fractions, isn't it? So, what is our function here? We have x over x plus 1 squared and x plus 2. So, if you resolve this, the first one is a linear factor which is repeated, isn't it? Have you seen that? So how do you resolve a repeated linear factor? The first one will be a over x plus 1, then followed by b over x plus 1 squared. You do it until you exploit the s power, isn't it? It is a linear factor, it's a constant over that linear factor. Then plus a constant over that linear factor until you exploit this highest power, which is 2, isn't it? Then you move to the next one, x plus 2 is also a linear factor, isn't it? Are we together? So if this is also a linear factor, it is also going to be a constant over linear factor. So that is how to resolve. That is how to resolve linear factors, isn't it? Are we together?
Yes.
Linear factor is just a constant over that linear factor, constant over that linear factor until you exploit its highest power, isn't it? A constant over that linear factor. So we are done. So from there, we look for the LCM. Remember, the LCM must be what is here, isn't it? Yes. So the LCM is x plus 1 squared into x plus 2, isn't it? Yes. Are we together? So you start x plus 1 goes here how many times? It goes, we have a in the numerator, so we have a into x plus 1, x plus 2, isn't it? Are we together? All that space is not enough. That space is not enough, we can put it down here. So we have the LCM is this, that is x plus 1 squared and x plus 2. So, start with this. A into x plus 1 goes here how many times? It goes x plus 1, x plus 2 times, isn't it? Yeah. You are done with that. Then plus b into x plus 1 squared goes here how many times? It goes x plus 2 times, isn't it? Are you together? Then the next one, plus c into x plus 2 goes here how many times? It goes x plus 1 squared times, isn't it? So then, you now expand that last part. If you expand that last part, x plus 1 squared, if you expand, you get, that's a quadratic identity. X plus 1 squared it is x plus 2x plus 1, if you expand it, isn't it? Are we together?
Yes.
Good. Not x, I mean it is x squared plus 2x plus 1, quadratic identity. Sidio? Good. That is what it is. Then if you expand this times this, if you expand this, x plus 1 times x plus 2, that is x squared plus 3x plus 2, isn't it? If you expand, you multiply this by this, you will get it to be x squared plus 3x plus 2. Are we together?
Yes.
So that is what you should have in the next line. After doing that, we collect the right time. So we start with x squared. What are the coefficients of x squared? So if we factorize out x squared, this is a times x squared. You get a is a coefficient, isn't it? Are we together? Then the next, there's no x squared here, there's x squared here, isn't it? So c, positive c times x squared, you get plus c. So you've collected the coefficients of x squared. So you are done with the x squared. Are you seeing that? You move to x. So plus x, what are the coefficients of x? The first coefficient of x is a times positive 3x, that is plus 3, isn't it? So the first coefficient of x there is plus positive 3a. You are done with that. The next x is here. Positive b times x is positive b. Senor, are we together? Because you factorize x outside. Is that okay? Is that okay?
Yes.
The next, positive c times 2x is plus 2cx, isn't it? Plus 2cx. So that is just plus 2c times x is outside, isn't it? So you've collected that. You are done with the coefficients of x. You go to the constant terms, isn't it? Are we together?
Yes.
You go to that constant terms. So plus, the first constant term is a times 2 is positive 2a. That is a constant term, isn't it? You've collected that. The next constant term is positive b times positive 2 is positive 2b, isn't it? So the next constant term is plus 2 plus 2b. You've collected that. The next constant term is positive c times positive 1 is positive c. Positive c. So you see, when you've crossed everything, it means you've collected all the terms, isn't it? So remember, denominator is the same as denominator, isn't it? Meaning numerator is the same as numerator. So it means the numerator this side is x. So it is the numerator we are comparing to the numerator. Are you seeing that?
Yes.
Are we together? Because the denominator is this is the same as the denominator. So it means the numerator, which is x, must be the same as the numerator, which is this, which we've collected like that, isn't it?
Yes.
Are we together? So from there you start comparing the coefficient of the constant term. There is no constant term this side, isn't it?
Yeah.
Meaning this side we have 0x squared plus 0 constant term, isn't it? Plus 1x, isn't it?
Yes.
So it means the coefficient of x squared is 0. That is why x squared is not on this side. The constant term this side is 0. That is why constant term is not on this side, isn't it?
Yes.
So you compare the coefficients. Are we together? So the coefficient of x squared here is a plus c, which is equal to the coefficient of x squared this side, which is 0, isn't it? Then the coefficient of x, the other side is what? 3a plus b plus 2c. And the coefficient of x this side is 1. Are we together?
Yes.
The coefficient of x this side is 1. Then you move on. The coefficient of the constant term. The constant term this side is 2a plus 2b plus c is equal to the constant term this side. The constant term is not this side, meaning the constant term this side is 0. Are we together there?
Yes.
So this is a system of simultaneous linear equations. So you use any method to solve a system of simultaneous linear equation. So go to the calculator and let us use the matrix method. Go to the calculator and construct this matrix 3 by 3 matrix, meaning a plus c is a plus 0b, isn't it? Meaning what is this matrix? This matrix is, means it is a plus 0b. That is why b is not there, isn't it?
Yes.
So this matrix, the coefficient, where there is no coefficient, you put the coefficient of 1. Are we together? So this matrix is 1, 0, 1, isn't it? 1, 0, 1, then 3, 1, 3 positive 1 positive 2. 3 positive 1 positive 2, then 2 2 1. So that matrix times ABC is equals to the solution, which is 0 1 0. Are we together? Are we together? Yes, we are. So from there, use Cramer's rule. So remember, here we are. This is the same as a over x plus 1. Then it is plus b over x plus 1 squared. Then it is plus c over x plus 2. Because I want to use this space. Are we together? Now, the first thing, you get the determinant of this matrix. So let us say this is matrix. The determinant of this matrix to be D. So what is D? Get the determinant of that matrix after feeding it in the calculator. What is the determinant of that matrix? It is a 3 by 3 matrix. You don't even find the matrix. Where's the matrix? Feed the matrix. Is this a matrix or a vector? No? Matrix number 6. Then you see matrix A number 1. Or you feed it, you fed it.
Number 1, sasa nataka kufidio nilifinya AC.
Good. So give me the determinant. Yes. Give me the determinant is what I want. So you just go to shift, then you go matrix is number. Good. Give me determinant. Then number 7, A. It was determinant, then go and select the matrix. Matrix A number 3. Sindio, what is it? 1. So you found the determinant of this matrix is 1. Once you find the matrix, yeah, you press AC. Yeah, then you shift, then you go to other matrix. I think it is in number 5 or what? It is number 4. Look where there is determinant. Determinant where there is matrix. Matrix is number 4. So you shift number 4 to get matrix. Then you are looking for determinant number 7. Then shift again to go back to matrices and check the matrix you are looking for. Matrix A. You want determinants of matrix A. So you select number 3. Yeah, so what's the determinant of that matrix? Is equal to sign, you don't press equal sign to give the answer. Have you locked it? Lock the matrix. Is equal to what? You've not fed the matrix, that's why you are getting feed the matrix. So we have 1, isn't it? Now, this is what we want. If you want the value of A is supposed to be, remember, if you want A is supposed to be equal to A, isn't it? So if you put D over D, meaning the determinant of the A over D. So for you to get the determinant of A, you put matrix B. The column of A is the first column. The column of A, you change with the solution, isn't it?
Yes.
Are you seeing that? The column of A, you change with that? You put solution where the column of A is. So for A, our matrix B is this 3, 1, 2, 2, 2, 1. Like this. Are we together? So if I want the determinant of this matrix, we are using Cramer's rule, D of A. Meaning A is the first one. It's the first column. You can see A. It's the first column. Are you using that?
Yes.
So the first column you substitute with the solution. Are we together? So the first column you wrap the first column and you substitute with the solution. What is the solution? 0, 1?
0, 1.
0, 1, 0. So it means you are now looking for the determinant of this. Gives you D of A. So what is the determinant of that matrix? Feed it as matrix B, isn't it?
As matrix B.
Or you can just replace that given matrix because you already used it, isn't it? So you can replace what you already used. Yeah. Good. That one you fed as matrix?
I've started.
Yeah. Number 7, determinant of matrix. Good. 2. You see? We're very fast and very efficient. You get that is 2. So it means A is D over A over D. Is 2 over 1. D is the same for everything. So you found your A value is what? You are done with A. Remember D, everything is using D. Now we want the determinant of D of B. Now D of B, you come here and look. This is the second column, you see? This is the second. Your matrix here, remember the old matrix, the initial matrix coefficient matrix is this, isn't it? So it means we replace the second column for us to get D of B, isn't it? So what is the determinant of this? Replace the second column. So the first column remains the way it is in D, isn't it? The third column remains the way it is in D. The second column is what we replace. The second column is for B, if we want D of B. Are you seeing? So the second column for B we replace with the solution. The solution is 0, 1, 0. So what is D of B? You see, this method is very simple. You can use it to solve a 4x4, isn't it? If in the case the calculator can reach that far. So what is D of B? -1. You see? So if you want B is equals to B, you just put D over D, isn't it? So it means it is D over B over D. But D of B you found is -1 and D you found is 1. So -1 over 1 is, you are done with B. So you see there's no need in going in those elimination substitution and waste of time, isn't it?
Yeah.
Good. Move to the next one. D of C, isn't it? So D of C, I can wrap this, I've already used. So D of C is the determinant of, meaning C is the third column. You substitute the third column of this coefficient matrix, isn't it? But this third column is 1. Are we together? The coefficient matrix is this. So we substitute this third column, we will have 1, 3, 2, 0, 1, 2. Then this column is now what we replace with the solution. The solution, isn't it?
Yes.
The solution is
0, 1, 0.
0, 1, 0. So what do you get to be the determinant of this matrix? What is B of C? -2. Are you seeing? Making work easier. You're using a simple machine, calculator. So C is equals to C. So you simply put D over D. So it is D of C over D. D of C is -2, D was 1, isn't it? So it is -2 over 1. So you get C is negative. So I will say you found the solution of A, B, and C using matrices, Cramer's rule, isn't it? You don't need to go to elimination and substitution. It's time consuming and you can end up getting wrong values, isn't it? So you just use Cramer's rule to get the values of A, B, and C. So from there, let us now go and substitute our values. Where there is A, put the value of A. Where there is A, put the value of A. A is 2. Where there is B, put the value of B. B is negative. Negative? -1, isn't it? Where there is C, put the value of C. C is -2. You're done. So you now come and integrate your problem. You start, you are given x over x plus 1 squared x plus 2, and you found this is the same as 2 over x plus 1, then it is the same as plus -1 over x plus 1 squared, then plus -2 over x plus 2. So what you simply do is to introduce integral for everything, isn't it? Then with respect to x. With respect to x. And you found that your original problem, this is this. So we'll put limits later after completing the integration, isn't it? Are we together? Is that okay?
Usikuja kwanza.
So start. This one is the same as you take 2 outside, so you have 2 dx over x plus 1, isn't it? Maybe you can bring this one next to make this simple and start, then this one to go at the end, isn't it? -2 into dx over x plus 2, then followed by this one to go at the end, -1 into dx over x plus 1 squared. Now, this one is simple, ln of x plus 1, isn't it? This one, ln of x plus 1, algebraic substitution, isn't it? What about that one? How do we deal with this? Now, if you look at this, over x plus 1 squared, you can use a completing square for it to result into an inverse function. You see, when you have x plus 1 squared, this is the same as x squared plus 2x plus. Senor, are we together?
Yes.
It is already a complete square, but it is still algebraic substitution. Do you know it is still algebraic substitution?
Yeah.
Because if you try algebraic substitution here, it is going to give the answer to be -1 over x plus 1. Very simple, isn't it? See, if you substitute x plus 1 to be u, you get the u is equal to the x. Are you seeing that? So it means you have the u over u squared, which is you have u raised to -2 du. So you simply, that is integration of a polynomial. Have you seen that? Yeah. So if you start with this first one, if you let u to be x plus 1, then it means differentiating u with respect to x, you get the u is equal to the x, isn't it? Yeah. So this is the u over the x. Algebraic substitution is working. That is a cake. You are done with this, isn't it? You go to this one again. If you let v to be x plus 2. If you differentiate v with respect to x, you get dv is equals to x. dv over dx is equals to 1, meaning dv is equals to dx, isn't it? So we now have dx is dv over v, ln of v, algebraic substitution. That is gone, isn't it? Yes. Are we together? So it is the algebraic substitution you try first before going to anything else, okay? Then move to this one. If you let t to be x plus 1, meaning dt is equals to dx. If you differentiate t with respect to x, you get dt over dx is equals to 1, isn't it? Meaning dt is equals to dx. So it means from here, what do we have? See, it means we have what? We have dx is dt over t squared. But t squared, it means t raised to negative 2. See, that is a polynomial. See there? T. Meaning algebraic substitution is working for everything. Are we together? It is working for everything. So give me the answer on the spot. So you can see the answer here is 2 ln of x plus 1, then minus 2 ln of x plus 2, then plus 1 over x plus 1. Are you seeing? Let me explain it. Let me draw a line here to explain. I've already explained this. du over u is ln of u, isn't it? This over this. Then this one is where I say if t is equals to x plus 1, then if you differentiate t with respect to x, you get dt is equals to dx, isn't it? So if you substitute dx is dt, that is dt over x plus 1 is t squared. That means you have t raised to negative 2 dt, isn't it? If you integrate t raised to negative 2, so it is negative 2 plus 1, you divide by the result power plus c. So that's a polynomial. See there? So from here, negative 2 plus 1, so you get t raised to negative 1 over negative 1, isn't it? Negative, see there? Yes. So you get negative 1 over, you get negative 1 over t, isn't it? Are we together there? So simplifying that, you get this, which in the end you get t raised to negative 1 over negative 1. So that is t raised to negative 1 is in the numerator, it means it is negative 1 over t. But what is t? T is x plus. So it means here if you have negative into negative, it becomes positive. Are we together there? Yes. It becomes positive. So from here, you now go, after completing integration is where you now put your limits, isn't it? Yeah. You now put limits everywhere. Put limits everywhere after completing integration. Then you put limits everywhere like that. Limits come at the end of the integration process. Are we together? So start. What do we get? Upper limit is minus lower limit. When x is 1, where there is x, you put 1, isn't it? Yeah. So this means it is 2 ln of 2 minus 2 ln of 3 plus 1 over 2. What do you get in the calculator when x is 1? What do you get when x is 1? You just say x is answer. So it is 2. Just say 1 is equals to 1. Then 2 ln of answer plus 1. Then minus 2 ln of answer plus 2. Ln of answer plus 2. Then plus 1 over answer plus 1. Over answer plus 1. What do you get to be the answer? Negative 0.31, isn't it? Then just press a C button and you press 0 is equals to 0, then replay is equals to what? Negative 0.386, isn't it? So remember, negative is positive, isn't it? So positive this minus this, what do you get to be the final answer? What do you get to the final answer? Negative 0.311 minus negative 0.386. 0.0 0.0 0.0 0.075.
Yes.
You are done. You've evaluated the definite integral. So here is where the task is. You must know which standard integration is applying, isn't it? You found this is resulting into logarithmic, this is resulting into logarithmic, this is resulting into polynomial integration procedure, isn't it? Good. Then at the end, you substitute your limits and you upper limit minus lower limit, then you should be able to get what you're looking for.